let's look at a few more examples of factoring perfect square trinomials. Okay, and so remember, when we see something of the pattern of a squared plus 2ab plus b squared, okay, we can actually factor that to a plus b squared, okay? Or in other words, again, a plus b times a plus b, okay? Or if we see something trinomial of the form a squared minus 2ab plus b squared, okay, that can be factored to a minus b squared, or a minus b times the quantity of a minus b, okay? And so remember, the middle term is sort of going to tell us which pattern to use, right? So if this one's positive, we'll be using, I guess this middle term here is positive, so we're probably going to be using the red, okay? Whereas in the other ones, notice again how our middle term is negative. So in parts A and C, we're probably going to be using the green pattern there, okay, instead of the red. All right, well, let's look at part A, right? So we have to make sure, first of all, that this front term and this back term are both perfect squares. So 1 and 16 are both perfect squares. I think some of us might be getting slightly confused here at this first part that we actually do, right? So all I'm trying to do is write part A. I'm trying to write it to look sort of like this, okay? And so therefore, I'm trying to figure out what can I write as a squared minus 2 times our a times our b, and then plus our b squared, okay, is sort of what I'm trying to figure out right now, okay? So I'm going to start with the first, like, well, what can I do first to get x squared, right? Well, that's kind of easy, right? So I can write this as x, or the quantity of x just being squared, okay? And what can I do to, now I'm going to jump way to my last term of positive 16. How could I write that as a number being squared? Well, I can write that as 4 squared. So we're going to think of x as our a in the pattern and our 4 as our b. So the minus 2 times a times b part, well, it's 2 times a times b, okay? And so basically we're just showing that, okay, this actually fits into the pattern. So now we can use that special pattern and say that our final answer is just going to be a minus b squared, okay? And this is now our final answer, okay? And so now we can check our work by foiling x minus 4 times x minus 4 and making sure that it's correct, right? So our first times our first would give us x squared, our outside would give us negative 4x, our insides would give us negative 4x, and last times last would give us a positive 16. Therefore, when we combine like terms, this is what we get, so we know that we're correct. Okay, it matches what we had in the original problem. Okay, let's now take a look at our next problem. So I have 9y squared plus 60y plus 100. So I'm going to check the 9 and the 100 here. Those are both perfect squares, so we're sort of ready to go. So I want to be able to write this now. I'm going to follow my red pattern because my middle term here is positive. All right, so I'm going to follow this as, I want to write this as a squared plus 2ab plus b squared. Okay, well, my first, I got to get 9y squared. Okay, so how can I write that as a quantity being squared? Well, I can write this as 3y, a product of 3y being squared. Okay, now I'm going to jump to my very last part. How can I write 100 as a number that's being squared? Well, I know that I can write that as 10 squared. So the 3y acts as my a, and the 10 acts as my b in the pattern. And so I can write the middle term be 2 times our a term times our b term. Okay, and we're just writing it so now it looks as if it should in that particular pattern. So we know that now this perfect square trinomial can be factored to a plus b squared, or in other words, 3y plus 10 squared, and that's our final answer. Okay, and so again, I'm just going to go ahead and FOIL this and make sure that I'm correct. So this is now 3y plus 10 times 3y plus 10. And I will go ahead and factor it. So 3y times 3y will give us 9y squared. Our outside here will give us a positive 30y. Our insides will give us another positive 30y. And last times last will give us a positive 100. Therefore, when I combine like terms, I'll get this as my answer. Okay? And let's go ahead and look at this very last one. Okay, I look at my first coefficient and my last constant. I realize that those are not perfect squares, so I'm going to take out a common factor here. I'll try to divide everything by 2 and see what I get. Okay, so this will give me now x squared minus 6x plus 9. Okay, now when I look at my first term and my last term, I know I can express those as a quantity that's being squared. So I'll write this as 2 times, I'll write this as x squared plus, sorry, it's not going to be a plus, it's going to be minus this time because our middle term is negative. So minus 2ab plus b squared. Okay, now 9 I can express as 3 squared, and so I'll write this as x and 3. Okay, so I'm just kind of proving that I can write it as this particular pattern, and now I'll go ahead and use the pattern to express this as 2 times x minus 3 squared. And that would be my final answer. Okay, and so again, I could go through and check this with FOIL. I will save you the check at this point, but again, you can see that some of these patterns might take a little bit of practice. Okay, but you know, it's something that definitely is going to pop up, and especially when we start graphing these things, we'll want to know these perfect square trinomials because they have some specific phenomena when we actually graph these.